All right, thank you, Greg. In addition to Greg, we also have Bill Mers, who I know is also the sales rep for some of you guys here, and he'll be doing a talk later on with regards to integrity testing. So while I'm covering final bottling filtration, I'll kind of skip over some of the integrity test things because then there's going to be an entire presentation focusing just on that afterwards because that's a common topic that we get a lot of questions on. So as Greg said, my name's Nate Starbard. I've been with Gusmer for about 5 years now as product manager for filtration products, and prior to that I worked with Millipore, so the company that supplies Gusmer with their cartridge filtration products, and before that I was with Gallo working on filtration projects and managing one of their filtration departments. So thank you guys all for coming today. So I'm actually going to skip over that one and just do a quick overview of the presentation. So as I said, this one focuses really on cartridge filtration, which for most folks is basically your pre-bottling filtration. While there are other applications for cartridges, 90% of it in industry, in the wine industry, is going to focus around your pre-bottling, your sterile membrane filtration. So this presentation will first go into an overview of the filters and types, talk about the different membranes, some of the differences you'll see between various cartridges on the market. Then we'll talk about the total cost of filtration. So that's something that Gusmer likes to spend a lot of time educating customers on and discussing. And what that really is the fact that your filter purchase cost is really only one thing to look at. When you look at your overall filtration process, you have wine loss, bottling line downtime, bottling attainments, chemicals, water usage. If you look at all of those total costs of filtration, a lot of times the non-filter costs are actually more important and a larger piece of your total budget than the filter purchase costs themselves. So you want to look at the total process optimization. If you guys have seen the Gusmer catalog, we dedicate a lot of space in there to talking about some of these things and optimizing your total costs of filtration. After that, we look at optimization and operation, cleaning and sterilization. That's another big topic we get a lot of questions on. Folks are often asking us what's the best way to clean, what's the best way to store, and if you look at cleaning as an optimization point, there's a lot of work that can be done there with most facilities to really get the best throughput out of your filters. I'll very briefly touch on integrity testing because again that's going to be gone into separately, and then just some final troubleshooting things. So specifically with regards to your final bottling filtration, it's really the last step in your process that's guaranteeing your final quality of your product. It's pretty unique in that it's one step that can guarantee your quality, it guarantees your specs, and it also is pretty unique in that it's a step that has a guaranteed test that tells you if it's working or not. There's two aspects to your cartridge filtration. There's integrity and then there's throughput. We always like to tell folks that call up with a filter issue that plugging isn't a failure. Integrity is a failure. If a filter fails integrity, then you have to worry about micro issues, and hopefully that never happens. But you do have that check. It's rare in any industry, especially the wine industry, though, to have a validated QA check on a specific process step that tells you 100% if the filter's working or if it's not working, if it's integral, and if it's doing its job. So it's an important step, and thankfully it's a step that has those checks built into it. So there's really two different types of cartridge filters. We've got one here. This is a pre-filter cartridge. It's a pleated pre-filter. It looks a little bit more like the one on the left. We also have some other filters kicking around the room that are other clarification and wrap type pre-filters. The one on the left, that picture of a microscope image, is a PolyGuard CR filter. So it's a wrapped polypropylene filter, which is basically 500 layers of compressed polypropylene strands woven around a core. The depth is about 1 inch, so that's what we talk about when we talk about a clarification filter or a depth type filter. It has a much thicker medium, and that's used for pre-filtration, DE trap filtration, water filtration, things like that. It really performs largely the same as other clarification products, like your sheets or your lenticulars. They may look a little bit different, but the method in which they work is pretty much the same as those types of cartridges. The other type of cartridge is unique to cartridge filters, and it's your membrane filter. And a picture of that is on the right. And a lot of times folks, if they haven't seen a close-up picture of a membrane, are a bit surprised. They think of a membrane as a sheet with just holes drilled into it, or that are exactly 0.45 micron or exactly 0.65 micron, and all the removal is done at the surface. And that's actually not the case with the membrane filter. Membrane filter has a matrix that's more like a sponge. So much of the removal of a membrane filter is actually not done at the surface, it's done in the depth. So even though it does have that depth, it's absolute rated, because it's been validated not just in the wine industry, but in many other industries to give you that guaranteed removal at its pore size. And that's really the biggest difference between pre-clarification depth type filters and your membrane filter. We call membrane filters absolute because they're guaranteed to get the removal at their pore size, and also because they are integrity testable, so you can double check to make sure they're doing their job. Whereas a depth filter, you can have unloading. So if you hit a depth filter with water hammer, pressure shock, if you run it way past its maximum differential pressure, you can get particles to migrate downstream. That will not happen with a membrane filter. If the membrane filter is integral, no particles larger than its pore size will pass downstream. The other big thing to note with depth filters is, you guys have probably heard the term nominal versus absolute here in industry. Depth filters, we'd never call them absolute. Here at Gusmer or Millipore, we don't call them absolute. Not only are they not integrity testable, but there's a range to their typical removal. So if you were to take 10 or 15 different clarification cartridges on the market from different vendors and line them all up, even if they were all a 1 micron filter, some may have a 50% removal at 1 micron, some may have a 75% removal, some may have a 95% removal. There's no definition or there's no rules around what you can call a filter. As long as it removes 1 particle at its pore size, you can call it that. At Millipore and Gusmer, we require our filters to have a minimum of 96% removal at its pore size. So if you were to get a PolyGuard CR clarification filter from Millipore, it's going to remove at least 96% of particles at its pore size. Many of them, like the BeviGuard pre-filter, will have 99.9% removal. So that is something you have to be aware of. We often get calls from customers. They are using another 1.0 micron filter, maybe from another industry. Water filters are notoriously low on retention if you just go to a water treatment company that also sells cartridges. And they'll swap it out with our 1 micron, and they'll think there's a problem because now the filter is plugging up much quicker. And that's because the filter's actually removing 100% of particles at 1 micron. So you can't always look at clarification and pre-filters as an apples-to-apples comparison without also looking at the retention. So you'll often want to ask the manufacturer, what is the retention of this pre-filter? The other big difference, of course, between depth filters, pre-filters, and your membrane filters is holding capacity. So in this picture, your pre-filters like the tree and your membranes like the umbrella. Ideally, you want the bulk of your filtration to be done by your lower grade, less expensive pre and depth clarification filters. As I said, your typical wrapped clarification cartridge is going to be about 1 inch thick. Your typical membrane is only 400 microns thick. It's about the thickness of a sheet of paper. So while that doesn't seem like a lot, if you can imagine a microbe at half a micron or 0.6 micron, it's actually got to travel through 800 times its depth to get through that matrix. And that's how you do get that removal. That's not just at the surface, but also through the depth. And this is important when it comes to maximizing your costs of filtration. Ideally, we tell customers you should be using 2 pre-filters for every 1 final filter. Right? A final filter is going to cost $300 to $400. A pre-filter is going to cost $150, $200. A clarification cartridge is going to cost $50 to $80. So you want to push the bulk of that filtration as far upstream as possible, so that way you're using the cheaper filters for the bulk of the removal, and that's what they're suited for. They have higher holding capacity, so you want to use that capacity and use the less expensive filter. Ideally, the membrane is really just there to catch the final micro. You don't want it doing any real heavy particulate filtration. So I think we touched on all of these topics already. You know, membrane has low holding capacity, absolute removal, it's integrity tested, and it's more expensive. So you don't want it doing the bulk of your process. You want to be using at least 2 pre-filters to every 1 final filter. And if you do have a situation where you're loading up a lot of pre-filters, because a plugged pre-filter will shut down your bottling line just the same as a plugged final filter. So if you're plugging pre-filters too often, then typically you may want to add a 3rd step, either a clarification cartridge or a lenticular, something like that. But it's important to manage that entire process and use the right filter for the job. Now, unlike pre-filters and clarification filters, membranes have very defined pore sizes. Ideally, a membrane is going to, well, in every case, if you're using a quality cartridge, it's going to remove 100% of particles above its pore size. There are now in industry some membranes that are non-retentive membranes. So if you do see that, you have to be careful. It may not be retentive at its pore size. We don't sell anything like that. Most major filter vendors wouldn't sell anything like that. So if you get a 0.45 micron filter, it's absolute, it's guaranteed to remove everything 0.45 micron and higher. So these are your common membrane cutoffs. They're really, unlike a clarification filter where you can get them in pretty much any pore size, and also those pore sizes are flexible because of their nominalness, membranes are really only available in certain pore sizes to industry. Other industries use 0.1, 0.2 micron, which we really don't get into wineries. There are a few wineries that filter down to a 0.2 micron. Most of the market here in the US, Latin America, Australia, South Africa goes down to a 0.45 micron filter. That's 95% of the membranes we sell at Gusmer are 0.45 micron, and then you sell a handful of 0.65 and 1.0 microns, typically to French winemakers. French winemakers like using a lot of 0.65 and 1.0 micron filters because that is what most people in France do. Most Italians, Spanish, again, Australians, Latin Americans, they filter just the same as the US. They go down to 0.45 in France. Most wineries don't membrane filter, and those that do typically go only down to a 1.0 or a 0.65. So in our industry, 0.45 micron is considered sterilizing grade. If you were to read general filtration papers or a textbook or talk to anybody from another industry, pharmaceutical, bottled water, sports drinks, Gatorade, things like that, they all filter down to a 0.2 micron. So if you read anything else and they refer to a sterilizing grade filter, if you just call a general purpose filter company and say, we want a sterilizing grade filter, they're going to ship you a 0.2. So it's pretty unique in wine and beer that we call a sterilizing grade filter 0.45 because a 0.45 for our industry removes all microbes of concern. So that'll remove all bacteria, all yeast, and then the higher organisms like molds and other things. A 0.65 micron will remove all yeast. It will allow most bacteria through. So Pediococcus, things like that will pass through a 0.65 micron membrane. And then a 1.0 micron membrane will remove Brett and the larger particles like molds only. That will allow Saccharomyces through. So for me personally, I've always used a 0.45 micron. That's what I recommend. I've seen a lot of studies over the years. I've never seen a winemaker reliably be able to tell the difference between a wine that's been either 0.65 or 0.45 filtered. So maybe somebody in here can, but I've never seen a study with any statistical relevance that shows that. So for me, if you can't tell the difference, why introduce that additional risk of bacteria contamination? So I would use a 0.45 if it's me. And really, we sell very, very few of the tens of thousands of filters we sell. Very few are 0.65 or 1.0 micron. But that is an option out there if that's something you wanted to look at. So here's a couple of shots of Millipore's manufacturing. So one of the unique things about Millipore is that they're primarily a biotech company. They're the largest filter supplier to pharmaceutical companies, and then they found that their filters, their PVDF membrane also works really well to wine and beer. So they don't really sell to other food industries. It's basically wine, beer, and then a smaller amount to bottled water. But the cool thing is that their filters for the beverage market are made to the same criteria, the same lines, the same specifications as their pharmaceutical filters. And this is in Jaffrey, New Hampshire, so I know there's a few Millipore customers in here. Prior to this year, PreFilters were made in Jaffrey, New Hampshire, and final filters were made in France. As of this year, all Millipore filters for wine are made in New Hampshire, so they're sourced right here on these lines. So you can see it's a pharmaceutical grade clean room, a lot of robotic technology. It's a pretty impressive manufacturing site. You know, as a filter person, one of the things, we won't go too much into the manufacturing and how they're built because it really has no practical implication, but one of the things as a filter person I don't like is when people say, a stick is a stick or a membrane's a membrane. There is actually a lot that goes into manufacturing membranes. There's a lot of differences between the different membranes. There are quite a few things that can impact its performance and process that happen in manufacturing. One small one that comes up quite often is that picture there is where the pleat pack and the end cap meet together. So you have a flexible pleat pack, that's your actual membrane, and then it's bonded into this hard plastic at the end cap. If you were to survey all filter failures in the wine industry, so when you actually fail integrity due to a real in-process situation, 80% of them come down to that bond. So Millipore recently adapted a new end cap that they patented that allows for double the potting of that pleat pack into the end cap, and we don't really see those failures anymore with Millipore filters. So there are differences in manufacturing. The other big one is membrane area. A lot of times folks will get a data sheet, and I'm guilty of this too. I get a data sheet, half the time I throw it away, right? It's marketing fluff. You you don't want to read that. But on the back page, skip the first 3 pages, but then on the back page, you have your specifications. And some of those numbers can be really telling when it comes to a filter, in particular membrane area. So I know there's a lot of larger customers in here who are using multi-round housings, 5 rounds, 8 rounds, 12 rounds, or bigger. The difference between a stated membrane area of just 0.6 meters squared or 0.75 meters square, 30% membrane difference, that's like putting 8 filters into a 12-round housing. So if you were to look at your data sheet, the most important thing to look at is your membrane area. And that's something that if you look at a filter and you say a stick is a stick, you can't necessarily tell that without looking at that. If you're loading 30 sheets versus 40 sheets into a press filter, or a plate and frame filter, that there's a difference in surface area there. But if you're just putting the same looking cartridges into housing, you may not realize that there's 20 or 30% less membrane in that filter, and that's having a big impact on your total throughput and your process costs. So definitely look at the filter, look at the manufacturing, look at its stress tolerance, its pressure ratings, its membrane area. They are different. The other big difference outside of the cartridges themselves is the membranes. So 10 years ago, this was a lot harder slide to present. There was tons of different membrane options on the market. There was cellulose acetate, there were nylon, there were polypropylene, PVDF. There was all these different membrane formats out there. Now the industry's really boiled down into 2 membranes. We continue to sell PVDF membrane. It's what Millipore has always sold with. It's basically the filter that built the company. We find it works best for the wine industry. Even though they do have PES filters they sell to other markets, everybody else has pretty much gone with a PES membrane. The 2 main differences between the membranes is that PVDF is symmetric and PES is asymmetric. Also, the membranes have different surface treatments. So a membrane is basically just a big piece of plastic. For all the special stuff that goes into it, you just take plastic, dissolve it in a solvent, lay it out, and let it evaporate, and that creates that sponge-like mixture. So since they're plastics, though, and the plastics that work best in this, they all start out hydrophobic. After you make that membrane, you have to do a special chemical treatment to make them accept water and liquid and wine so that they can be integrity tested and be used in process. That surface treatment has a big impact on how the membrane performs. So when we talk about symmetric versus asymmetric membranes, picture on the left is an asymmetric membrane. That's a PES membrane. You can see that the upstream is largely a lot of void volume, and then it funnels down into the final pore size of the membrane, whereas PVDF is symmetric. It's the same consistent pore size throughout the depth. So this can have a couple implications, mainly in integrity testing. Since your integrity test specifications, like you'll see in the next presentation, are built around your final pore size, this has a much smaller area of that pore size. So the bubble point's lower and the diffusion's a lot higher. So the 2 filters do integrity test slightly differently. Fundamentally, the procedure's the same, but you do have to be aware that the specifications are a little bit different. The other issue is with flavorings. There's a couple people in here. We just did this seminar up in Napa and Sonoma. Nobody up there uses any kind of flavorings, but if you were doing any kind of blackberry merlots, wine coolers, a lot of products we see out on the East Coast, then flavorings can be very difficult to rinse away with asymmetric membranes. That's something you have to be cognizant of if you are doing flavored products. It's much trickier to rinse them out of an asymmetric membrane because the way they coat and get in there and then change the surface tension.
So would concentrate work the same way?
Is it a wine concentrate or is it? So a wine concentrate really shouldn't change the surface tension. It's more of the flavorings that have different oils and things in them.
So what if it were to be like a concentration or something like that? That would be a lower concentration?
No, typically I wouldn't expect more artificial stuff.
Okay.
Typically a pure fruit concentrate, because we deal with that a lot now in the brewing industry, you wouldn't typically see an issue with cleaning. It would clean largely the same. It's a tougher, concentrates usually are tougher to filter just because of viscosity and the concentration of materials in there. But with regards to cleaning, no, it shouldn't have an impact on your integrity test. So the other big difference that comes about due to that surface treatment is the protein and color binding. So basically the patent that built Millipore was the PVDF membrane patent that relates to protein binding. In pharmaceutical market, your proteins are your product, so having lower protein binding means millions of dollars more product going out the door and not being deposited on your membrane. In the wine industry, lower protein binding means that you have less stuff on the membrane when you do your hot water cleaning, and that gets permanently baked on and causes a loss of filterability. So lower protein binding means more cleanability, more cleaning cycles, and then hopefully longer throughputs and higher gallons throughput for those same filters. So sometimes I put this slide up here, and it's not meant to scare folks thinking that any membrane's removing a lot of stuff. Really, no membrane is going to remove any noticeable protein or color from your wine product. I've seen 96 round 40-inch housings, these massive housings. They're not going to change your product at all either. So it's not so much a situation that you're removing things from your wine with higher protein binding, it's the fact that those proteins are then bound to the membrane, which then causes a quicker loss of filter capacity and fewer cleaning cycles and then lower throughputs. So this really has more to do with the cleanability than anything that would change your product. The other issue is with strength and robustness of the membrane. So as you can imagine, this is void volume, there's just less plastic there. So when you get to more open pore sizes like 0.65 or 1.0 micron, PES filters typically have a much lower pressure tolerance. And it's hard to find one that's made out of a 1.0 micron. So if you were somebody that wanted to use a 1.0 micron, you'd probably have to use a PVDF filter just because of that greater stress tolerance at the more open pore sizes as you start to open up those pores. So really that's why we recommend PVDF, because all of those things generally lead to higher throughputs, lower numbers of issues, and then gets you a lower total cost of filtration. Which you've heard me say the word throughput several times now. That's really the key metric. I hope everybody in here knows their throughput. So how many gallons per change out, how many gallons per filter you're getting. You really can't look at your filter process, select a filter, or know really what you're even paying for the filter without looking at that number, right? If you have two filters, one's $400 and gets 100,000 gallons through it, one's $200 and only gets 20,000 gallons through it, that $200 filter is actually costing you $1,000. You really can't look at filter costs without knowing how many gallons are getting through it. The two have to go hand in hand. And then once you know your throughput, you work on optimizing it. You work on cleaning procedures, you work on flow rates, you work on all of those other things that you can do to get more throughput out of your filter. We've helped some customers increase their throughput by a factor of 10x over a few years. So particularly in this area where you have a lot of folks that are spending quite a bit of money on filters, if you're spending $50,000 a year on filters and now you can get 10 times the flow rate out of it, that has a huge impact to your budget. So there's a lot more potential, particularly in this area, to optimize your filtration. So when we talk about the total cost of filtration, there's really three different aspects we're looking at. Again, you have your throughput. You want to get as much throughput through your filters as possible, and then that directly relates to your filter cost, and then you have your total cost of filtration. So I know in this area, one of the big rules of thumb for bottling line downtime is $6 a minute. So every minute that your bottling line is down, you have a crew standing there, you have soap going on the conveyor, you have compressors running, pumps are running. It generally has an industry accepted value of about $6 a minute cost. So if you have filters on particularly multiple lines, and you have filters that are plugging up a couple times extra each week, takes 2 hours to turn around a filter, there's a huge cost, not just to your bottling attainments, but to those costs of having your folks and all your equipment running. Also, every time you plug up an 8-round or a 12-round housing, that's quite a bit of wine loss. You look at cleaning, every time you have to clean the filters, 30, 40 gallons a minute, times 2 hours of water going down the drain. In this area, water's not as big of an issue. You go up to Napa, water's huge. If they're sending an extra few thousand gallons of water down the drain, that can be a big impact. I know it's important everywhere in California, but certain areas are particularly hit hard by water restrictions on wineries. All of those things, if you really look at them, usually far outweigh your filter cost. Everybody really looks at the filter cost, but if you look at your bottling downtime, your wine loss, your water usage, all of those other things, which sometimes are hidden in non-production budgets, right? Most production managers aren't responsible for water. That comes out of facilities, or chemicals comes out of facilities. But if you look at all of those other costs, they're a huge part of your total filtration budget, or your total filtration costs, I should say. And then obviously a single QA incident. You should never see a legitimate integrity failure on a filter. One of the things that bothers us is when we run into a customer that's kind of lackadaisical about integrity failures. Yeah, I fail integrity every few months, or yeah, we have an issue. You should never see that with our filters, and you should never see that with any filter. If you're failing integrity, that's a major issue. That means your product is at risk on that batch. So if you have an integrity failure, let us know, let your supplier know you want to troubleshoot that. I can say 90% of the integrity failures we deal with are due to shipping. UPS and FedEx by far damage the most filters, or cause the most filtration issues in industry. So always be cognizant of shipping damage and do a careful inspection on the filters. But if you do get a real filter failure that results in a QA incident, there goes your filter cost for the next 50 years. There's nothing more expensive than a single QA incident. So if you do have a filter that's giving you repeat issues, you may want to look at that, look at changing it, look at working with the vendor to fix that, because that's the other big cost, and that's a cost that really shouldn't happen. So people hate spending money on filters. Winemakers have no problem writing a $100,000 check for bacteria, yeast, barrels, oak, shiny new tasting rooms. Nothing gets a visceral reaction from people more than buying a filter. Nobody wants to spend money on a filter for whatever reason. But when you really break it down, if you're getting 100,000 gallons through a 30-inch filter, the cost of filtration is $0.004 per gallon, which is 0.08 of a cent per bottle. So 0.0008 cents per bottle. That's lower than your cost of SO2. That's lower than your cost of the label. That's the lowest process cost in industry. In the entire wine process, that's your lowest process cost, and yet that's the process that's guaranteeing your final product sterility, that's guaranteeing you're gonna meet your specs. So we just like to, and we get that people still, even though I say that, we get people don't like writing filters. We want to help you optimize. That's a big part of my job. That's a big part of what our sales reps do. We do a lot of work with getting people to spend less money on filters. Even though that seems counterintuitive, because we're a filtration company, we feel the more optimized your process, the better our filter shows, the happier you are with Gusmer, and the happier you are with Millipore. So we want folks to be running an optimized process that's getting really good throughputs through their filters. Because we know people don't like buying filters. And we get into a little bit more of the sizing and the optimization. Wine industry sizing is actually pretty easy. It's pretty consistent at about 10 gallons a minute per filter. That's pretty consistent here in California if you've got good clarification. With smaller facilities outside of California, things can get a little bit less standard than this, but 90% of wineries in California are going to size based on this chart. So 7 gallons a minute is 1 filter, 25 gallons a minute, 3 filters, 40 gallons a minute, 5 filters, and so forth. One thing that not a lot of facilities do that really doesn't make sense for the wine industry, but it's what the wine industry does, is everybody in the wine industry wants to have the same size final filter and pre-filter, which if you're running a good process and you're plugging your pre-filter twice as often as your final filter, that doesn't really make sense. You should have more filtration capacity. Right? It doesn't matter if a pre-filter plugs or a final filter plugs. Either way, your line's down and you're having to either clean or change out the filters. So if your pre-filter's plugging up twice as often, you should use a bigger pre-filter housing. There's a few folks now that are starting to go down that route, but most people still, they size the final filter and then they want the same size housing on both. And there are benefits to that. You've got the same size gaskets, you've got the same spare parts, but really, pre-filters should be sized bigger than the final filter, and that's what most industries do, but not so much in the wine industry. Water filtration is usually sized a bit higher just because there are higher flow rates at water. And then if you're doing any kind of specialty cartridge processes, so if you got DE trap filters, catching fines, if you're doing any kind of clarification for tar traits, special type processes like that, come to us, let us know, and then we'll size that out for you because those are a little less kind of cookie cutter. One important thing with system sizing is most often when customers come to us looking for the recommended size on their line, because these are tied to the filler, they give us the average bottles per minute of a filler. Right? They'll come to us and say, I'm running 100 bottles a minute, I'm running 200 bottles a minute. That's your average filler output. That's not your maximum flow rate through the filters. So if you're sizing based on your average filler output, you have to add 30% on to account for your maximum flow rate. So you want to add 30% onto your bottles per minute and then size your filters based on that number. One thing that I'm a huge fan of, particularly in this area, I think there's a lot of customers saving a lot of money, really helping their operation out, is dual filtration skids. So this is something that's really starting to finally catch on, and I think anybody who's running an appreciable, larger size bottling that doesn't have dual filtration skids is probably leaving a lot of money on the table. So what this entails is you have identical pre and final filters, so the same process you're running, but you have 2 sets of the same filters side by side. You've got 1 inlet, 1 outlet, but the filters are capable of being cleaned independently. So as you're running on 1 filter set and it starts to plug, you can get your second filter set cleaned and sterilized and then switch over to it. So that way you never shut down bottling. You can also bring down your filters at their optimal cleaning. So a membrane filter is typically fully plugged at 40 psi differential. So differential pressure is your inlet minus your outlet. Most people are going to start to lose flow at around 32 psi. The optimal cleaning is 28 psid. So you don't want to run your filters until they're 100% plugged, then take them down and clean. You're not going to get as good of a cleaning out of it. So ideally, you want to take those filters down a little bit early. This allows you to do that a little more flexibly. This also allows you to get every last drop out of your filters, every bit of capacity, because you're not shutting down the bottling run. Right now, if you're running just a pre and a final filter, and you know those filters, and those filters have just plugged, and you still have a large batch to go through, or you have another day's run, the tendency is going to be to throw away those filters rather than clean them. With this process, as long as you can clean that second step, that second set, before the other ones plug up, you can keep running. So with a lot of large wineries now with this system, their spec to throw away filters is that it plugs within 2 hours. So if it's still got an 8-hour run on it, that may not be acceptable for some facilities, but if you have dual filtration skids, you can just keep bouncing back and forth between them, never shutting down bottling, getting more cleaning cycles in, and then using every last bit of capacity on those filters. I've seen facilities go to this and in some cases increase their throughput through their filters by 40, 60, or even more %. So this can have a huge impact. And if you think about the costs, a lot of times folks think housing's a big chunk of stainless is expensive. The average cost of a 3-round is $2,500 bucks. So if you're running 3-round housings, 2 housings or 5,000 plus some piping and valves, $6,000. If you can extend the life of your filters by 50% or more, never shut down bottling, have that greater flexibility. You know, you always have a backup set. One of the worst things when you're running a filtration is at the end of the run, the VA film on the top and the solids that have settled to the bottom start to come together, and then you plug up your filters with 50 gallons left, 100 gallons left in the tank, and what do you do with that wine? Do you do a 2-hour cleaning to try to get that last little bit of wine out? Do you just send it to reclaim? Do you send it top off another tank that's now going to kill that tank's filterability? What do you do with that wine? With this instance, you don't run into those situations where you've now got to come down, extend out the shift. So it gives you a lot more flexibility as well. It also allows for specialty cleaning procedures. So not only can you do a better cleaning by taking the filters down earlier, but you can do things like citric acid rinses if you have any flavor issues, if you're running flavored product, or if you have a carbonate issue on your water, you can do that. What's common in the beer industry, few people have done it in the wine industry, are things like beta-glucanase soaks. So if you have a beta-glucan issue, you can add some enzyme, let it soak in the filters to clean that off. So you can start to do specialty cleaning regimens that in some cases can help as well. So I'm a huge proponent of this. One of the other industries we've started seeing a lot more traction with this on is mobile bottlers. So I don't know if there are any mobile bottlers in this room, but this can save you from having to spend a lot of extra time on your customer's site. So when you show up and you've got a customer that just has poorly prepared wine, and you're not getting paid by the hour or by the day, you're getting paid by the case, this will save you from having to spend 3 days on that job that you originally was hoping would only go in 1 day. So this can have a big impact on mobile bottling operations as well. So once you've got your filters up and running, they're actually pretty simple. You want to track your throughput, you want to track your differential pressure. So your differential pressure is your inlet minus your outlet. That tells you how plugged your filter is. It's a direct ratio. Your filter's fully plugged at 40. That means if your PSID is 20, the filter's half plugged. Half the capacity for that run is used up. The other thing you want to watch out for when you're operating is the formation of air and gas bubbles. So you always want to vent your housings. This is something, particularly in this area, we do see a lot of, and we're starting to see more and more of it as customers are starting to spritz a lot of their wines. So adding 30 ppm, 60 ppm of CO2 to like a white wine, that's adding a gas that can then come out of solution, particularly if you're processing outside or it's hotter out. And usually, you can see the housing over there, it's a tall dome. That's usually the high point in your process. So any CO2, N2, oxygen that comes out of solution, it's usually going to settle in the top of that dome. And then that starts to create an air bubble. The membranes, if they're wetted and you have an air bubble up there, as it starts to overlap, it won't allow flow through the filter. So we've gotten filters back from customers where the top part of the filter is pure white, looks like it just came out of the bag, and then you start to see this gradient and the bottom is red, like it's processed wine. And that we know instantly that there's an issue in that facility with air bubbles, or they're running a carbonated product and it's overlapping, and you're essentially not using part of your filter in that instance. So if you don't have a sight glass, that housing has a sight glass on it. If you don't have one, I recommend getting one. And then the other option is, if you're walking through your facility, look for the condensate line. You're processing cold product, there's going to be a condensate line that forms on that housing wherever the fill level is. So that's sometimes a quick way to go through, but you'll want to always make sure your filters are vented. Not just during operation either. You want to make sure they're vented during CIP. Usually there's a higher DO and there's more entrained air in your CIP process, especially when you're switching back between cold and hot water. If you get an air bubble that forms during CIP, you won't get the contact in the top of that dome. I've seen a lot of housings where you flip the dome, you look in there, everything's nice, shiny stainless up until the end of the dome, and then you have a biofilm, you have growth in there. And it's on the upstream side of the filters, so the filter should still filter everything out, but it's certainly not good to have growth inside your dome. So it's important to also vent during CIP processes as well. But once they're running, cartridges are pretty easy to run. You check the differential pressure every now and again, you vent them, and then on a larger scale, on a facility scale, you want to track your throughput. But they really don't need a lot of operator attention. You don't need somebody constantly watching it, changing settings, and handling the filters that often. One of the most, I wouldn't say frustrating, but one of the trickiest things is when we get a call and somebody says, my filter failed. And then we ask, well, what happened? And they tell us it plugged. Plugging is not a failure. Plugging is the filter doing its job. If a filter plugged, that means it did its job, and now we have to look at why it plugged. Did something change with the wine? Did the filterability, does it have a poor filterability? Is a screen broken on a pressure leaf? What happened that caused that plugging, if that plugging was out of normal for the facility? If normally they get 100,000 gallons through the filter and now they've only gotten 30,000 gallons through the filter. Is there a new additive? Was there a process change? What's going on? But the plugging in itself is not a failure. A failure is integrity. Your end of life should be plugging based, so every filter eventually should plug. And particles will plug differently. So if you have an issue with DE, for instance, that has very little impact on your filter capacity. DE really doesn't plug your filters all that much because it's a hard particle. It leaves flow channels, it builds up on the surface of the membrane. It really doesn't do much, and it's very easy to clean off. The hardest thing with regards to plugging are your deformable materials, colloids. Usually microbes aren't present in too high a concentration to cause an issue. Bentonite, there's nothing worse for filters, not just cartridges, but every filter, than bentonite. When I worked at Millipore, even on pharmaceutical projects, if we wanted to plug a filter for a study, we get wine-grade bentonite. Companies that make filters for other industries still buy wine-grade bentonite in order to plug their filters. Nothing will plug filters better than bentonite. So you never want to not have a well-racked wine or do anything where bentonite can get into your filters. Those materials are really what causes a loss of your filter capacity during a run. And that's because of the way they blind off on the surface of the membrane. I think we touched on most of this, but one thing in here that I think surprises a lot of customers is the impact that flow rate can have. If I were to take two identical tanks of wine through two identical filters, 100% same process, except for flow rate. So 1,000 gallons of wine filtered at 20 gallons a minute versus 1,000 gallons of wine filtered at 40 gallons a minute. At the end of the run, the one that was filtered at 20 gallons a minute is going to have a much lower differential pressure. It's going to be much less plugged. Even though the particles have stayed the same, even though the gallon size has stayed the same, running at that higher flow rate blinds off the membrane more effectively. We call it face velocity in the wine industry. You want to have the lowest possible face velocity, and that'll help during the run extend your filters more. That's not really going to have a long-term impact of the filters. You're not going to degrade the filtration capacity over many runs much differently, but during the run, your differential pressure is going to increase much quicker the faster you run. So we always tell customers to run at the slowest consistent flow rate as possible. And sometimes that's tricky, with filler operators that don't realize there's more than just off and high speed on their filler. You can use that filler surge tank or that filler bowl as a good surge tank. You can slow down your flow. You can tie your filler to your pump sometimes and change the speed on this. So you want to always run at the slowest consistent flow rate as possible. And then the biggest thing that's going to have an impact in many cases on your filters is the filter cleaning. So really there's two purposes of cleaning. The first one is to eliminate any flavor or color carryover, and the second one is to extend the life of your filters. If you didn't clean your filters, they would plug up and lose their capacity much quicker than when you clean them. As your differential pressure goes up, you shut down, you clean them, your differential pressure goes down. No filter can be 100% cleaned. They're always going to plug up. Eventually they're going to lose their capacity, they're going to plug up, and you're going to have to change the filters out, even in a perfect process. There's two main reasons for that. Two things that really cause your long-term loss of filter capacity. That's your bound proteins at high temperature. So going back to the membrane characteristics, anything that's bound on the membrane when you get to 135 degrees or higher on your cleaning is going to be permanently lodged onto the membrane, and that's going to cause a loss of capacity. So the goal of any cleaning process, one of the main goals, is to remove as much material from the membrane as possible before you get to your hot water step, before you get to your 180 degree step. The other big cause of loss of life on your filters is going to be from your water. Many people's water actually does more long-term damage than their wine does, which seems counterintuitive. A lot of folks see clear water, they think it's got an easy filterability, but there's a lot of dissolved materials in there that permanently build up on your membrane and then don't come off. So we've seen many folks, and I talk about this a little bit more later on with regards to softeners and things, we've seen a lot of people optimize their water and see a huge, sometimes double the filter throughput than they had without any water treatment. One comment I always like to make, don't assume that municipal water supplies are the cleanest. Some of the dirtiest, with regards to filtering, some of the dirtiest, most plugging water supplies I've ever seen come from municipal sources. Some of the cleanest water I've ever seen comes from wells. Wells are variable. Some wells are poor quality, some wells are higher quality, but don't always assume that municipal sources are cleaner. Those are treated for health effects. They're not treated for contaminants that are dissolved that may be building up or plugging your membranes. So that's the other big thing. And one way in which we often tell if a customer may have a water issue is if you have a skewed pre-filter to final filter ratio. So I said earlier on, we recommend customers, if everything's dialed in, you should be using at least 2 pre-filters for every 1 final filter. So if I look at a customer's spend history and they're buying 1 pre-filter for every 4 or 5 final filters, there's one of 2 things going on. Either they're not using a tight enough pre-filter, they're using somebody else's 1 micron that's only 50% retentive, and then they need to tighten down the pre-filter, or they have a water issue. So if they're using our pre-filter, which we know is a tight pre-filter right above the pore size of the membrane, and I see 1 pre-filter to 3 or 4 or 5 final filters, that's a water issue. And if you can change that adjustment, then you can see the payback that'll happen on your filters. So usually that'll justify softeners or water filtration or something else. So that's one common way we can tell that there's a water issue. So as I mentioned, the whole goal of cleaning with regards to throughput is you build your differential pressure, you clean, you drop it down, you build it up again on your next run, and then you hope that these repeated cleanings push out your filter change out. You'll notice I have in bold red letters there, cold water rinse for at least 10 minutes. A lot of customers, particularly recently with the water restrictions, are trying to get away from doing that cold water rinse. They think the important part of the cleaning is the hot water cycle, right? That's the cycle that gives you sanitation. That's the main, focus of QA usually is that 30 minutes at 180 degree water, that at 180 degrees that both cleans and sterilizes. But with regards to throughput, that cold water cleaning is sometimes more important. That cold water rinse gets rid of a lot of those materials before you get to that hot water step. We've actually seen, in a couple cases, large customers spending a lot of money on filters do away with their cold water rinse in order to save water. Instantly, their filter spend will double. That is a very terrible thing to do with regards to cleaning your filters. You always want to do a cold water rinse beforehand. One of the best things you can do in an ideal world would be to do a cold water rinse, then do a warm water rinse for a while, and then gradually step up to your hot water. Unfortunately, most systems in the wine industry don't give you the ability to hold an intermediate temperature, like 120 degrees. But fortunately, most systems in the wine industry also take 15, 20 minutes to come up to temperature. So you run your cold water for 10 minutes, you switch over to hot water, it takes 10 or 15 minutes to get up to 180 degrees, and that gives you a nice intermittent warm water rinse, and then you get up to your 180 degrees, and that's really the best. You want to do as much of that intermittent time as possible. If anybody here has ever cleaned a filter with the outlet open, you run your cold water through the filter, you see a ton of color and stuff come out. Eventually it goes clear. You up the temperature 10 or 15 degrees, more stuff will come out. You'll see more color come out, and then it goes clear. You can keep doing that all the way up to 180 degrees, and every time you step up, you'll see more material come out. The goal is to get as much stuff out as possible before you get to your 180 degree, and then those bound proteins are permanently lodged onto the membrane. This cold water cool down at the end actually relates more to integrity testing and making sure your filters aren't damaged when they're hot. So it really does nothing for cleaning. At this point in time, your filters are cleaned or not cleaned. So you want to cool down at the end, because when you go to do your integrity test, the integrity test is based on gas. So if you have any contraction or expansion due to temperature changes, then that can throw off your integrity test. It can cause either a false failure or false positive, depending on which way the temperature goes. The other thing about the cold water cool down is cartridges are most susceptible to damage when they're hot, right? For everything that goes into it, again, it's just a hunk of plastic. So when it's hot, it's pliable, it's more malleable. So a lot of times compressed gas supplies have a high pressure. So if it's hot and you open up your gas supply to do your integrity test, you can damage it that way. So that's really what this cold water cool down has to do. If you were to run your sanitation and you weren't going to integrity test, you weren't going to do anything to the filter, you could walk away and let it cool down on its own. But if you're going to do things to your filter like integrity test, you want to do that cold water cool down. One thing we always recommend with cleaning, especially with larger customers, is try to use about the same flow rate as you're running your process. If you're running your process at 50, 60 gallons a minute, you don't want to try to clean with 2 gallons a minute of flow. Volume matters, temperature matters. You really have to use about the same flow rate as your process. And then we talk about the gradual warm and hot. So if I could design a system, a hot water system for cleaning filters, I'm going to do ambient water, whatever the cold water is, for 10 to 15 minutes. I'm going to program 120 degrees, hold that for 10 or 15 minutes, and then have a gradual ramp up to 180. That's ideal. Most people don't have that capability to hold at 120 degrees. But if you were looking to do everything perfectly, that would be it. One of the good things about the wine industry is that you can clean and sterilize at the same time. You know, we get a lot of questions on filters if people can use chemicals or steam to sterilize. You can. I personally don't recommend it, and I wouldn't, because then it's redundant. You need 180 degree water to clean a filter. 180 degree water can also sterilize the filters. So in that case, steam and chemicals is just redundant. It's an extra cost, and in many cases, those are less safe in most winery environments. So I personally would never use steam. I don't really recommend it. Steaming is by far the easiest way to damage cartridges. There are a lot of customers that are using steam successfully, but I think ideally you just stick with hot water. So I mentioned before already that you can see the difference here in your differential pressure spec. So this is the specification before a filter is broken. At ambient temperature, it's 80 psid, and that's kind of an industry standard number. Millipore doesn't fail until 120. They've got a big safety factor built in there. But up at 180 degrees, you can see it drops down to 25 psid. So that's why when you're at hot temperatures, you do need to monitor your differential pressures, water hammer, pressure spikes, things like that become a lot more important. And then, as I mentioned, that 135 degree temperature is important. That one customer that I saw recently who started pre-circulating their hot water and saw their filter spend double on the same gallons, their filter almost looked like a glazed pot. It almost had an enamel on it. They were just baking everything that was right on the filter. So you want to get as much of that material off before 135F as possible. So water can have a huge impact on your filters. It's not just wine going through your filters, it's water. And in some cases, waters will have clays in them, they'll have mineral deposits, they'll have stuff that builds up. Most important thing for water is softening. So a lot of times folks will ask us, I know I need to soften it, I know I need to filter it, which is more important? As much as I think filtration is important to your water, softening is going to do more for you. One thing that I've seen a lot of issues with folks out here is using your well companies or using kind of a general purpose non-water specialist company to design your softeners. They'll just go to Home Depot, grab the off-the-shelf softener, pop it in line. Not all waters are the same. They have different elements in them. They're different resins. So a softener is essentially a tank of resin that absorbs that material that otherwise would be deposited onto your filters. Not all waters are the same. If you have a higher magnesium content, there's different resins than if you don't have that, or if you have a calcium issue. So have your water tested, design the right softener that's going to work for you, and you'll see much better performance. I have seen customers just put in the wrong softener and they still have hard water, they still have deposits, they still have issues. So you want to make sure you use a real water company that's going to test your water and design a good softener for you, and then you can also go to filtration. Now the best thing to do, which not a lot of folks will do, not a lot of folks can justify the cost on it, is RO. If you have an RO, or if you're interested in investing in a water RO, a lot of industries use them for their water, that's really going to do the best job. Then you're not going to have to worry about softening, you're not going to have to worry about filtering. That's giving you the best quality water for your CIP. So I do think a lot of wineries could benefit from adding that, but most people aren't going to spend another $30,000 or $40,000 on a dedicated water RO system. But that really gives you the cleanest water for your filters. But it's not uncommon for us to see folks who have popped a softener and a filter in, and automatically their bottling filter spend goes down by 25, 30%, sometimes more. So this can have a big impact, again, depending on the quality of your water. And I won't go too much into integrity testing just because that's the focus of the next presentation. What I will say about integrity testing is the most important time to do it is on install. 95% of your integrity issues are going to happen on install. The vast majority of integrity failures that we see are from UPS and FedEx. Always check your boxes for damage. Open it, look in the bag before you even open the bag, make sure nothing's cracked, nothing's damaged, and then make sure you do your integrity test on new filter install. Once the filters are installed and they're running wine, that's the easy part. It's hard to break a filter when it's just running wine. Usually your issues are going to happen on install, either rolled O-rings, damage during the install, shipping damage. That's really when almost all of our integrity issues we see happen. So again, your end of life for your filter should be throughput based. You should maximize your throughput, and when you throw away your filters, that should be the reason. It shouldn't be an integrity issue. If of the tens of thousands of filters we ship more filters to the wine industry than anybody else. We only get a few, literally a handful of actual integrity issues a year that then we want to work with you on to help figure out what happened. Was there a slug of caustic that got in there? Is there a water hammer or pressure shock? Is there a steaming issue? What caused that failure? Because the filters shouldn't fail. If they fail, there's a cause that we want to work with you on with regards to our filters. So always never take the approach that filters just fail or that's something that should happen. Always contact us if there is an issue. And one of the good things about Millipore, and one of the reasons I can say that, is because every filter that leaves their plant, first off, they integrity test their membrane. So every foot of membrane, as it's getting put into the roll, is integrity tested. And then every 10-inch element, this is a pre-filter, so it doesn't have elements, but every 10-inch element on a membrane is integrity tested. And then every finished device is integrity tested. So essentially, that membrane's been integrity tested 3 times by the time it leaves the factory. So we know there's no membrane defects, there's no potting issues, there's no issues on the seams or the pleat packs. So we know it's good when it leaves, so it should not fail in process. I had to add these qualifiers recently to this presentation. I used to just have up there, we want every 30-inch filter to get 100,000 gallons through it. Now, in a larger bottling operation with good clarification, in a multi-round filter, 3-round or higher, typically that's what we want to see. I want to see a 3-round filter get at least 250,000 gallons, preferably 300,000 gallons. I want to see a 12-round filter housing get 1,000,000 gallons. Those are kind of our benchmarks. That being said, we've got some customers that have now optimized to the point where they're getting 3, 4. We've got one that recently got 5 million gallons through a 12-round housing. So just massive optimization there. And they're a large customer spending a lot of money on filters, so of course that optimization has a bigger payback to them. But when you get into smaller customers, if you're running a 1-filter setup, you're trying to rack off instead of doing a clarification, then you have to be a little bit more careful with these numbers. The process is going to be a little more variable. But ideally, that's kind of your benchmark. So if you don't know your throughput, then you don't know where you'd stand on that scale, and you should know your throughput, and then we can work on optimizing it. All right, that's it. Any questions from anybody? And I'll be around at lunch, and we'll all be around for questions the whole day. Go ahead.
So you suggested not using steam for cleaning or sterilizing. Why?
So steam does not clean. So you still have to use 180-degree water to do a good cleaner. So in that instance, steam becomes redundant. The other issue with steam is you have to steam a filter dry, so it kind of limits the way in which you can operate. So steam really only works in a 1-shift operation. Because you have to let the filter dry out before you do the steam. So you'll see in the next presentation about bubble point, since steam's a gas, the bubble point of a 0.45 micron filter is 28 pounds. The maximum pressure spec is 25 pounds. So in order to get that steam through a wet membrane, you actually have to break the filter. So you have to steam dry, which means the only way to really run steam in most operations is to do your bottling, do your filtration rather, on 1 shift, clean at the end, let the filter sit overnight to where it's somewhat dry, and then you can steam for sterilize on startup. So personally, to me, I think you just do it all with 180-degree water. You get your cleaning and your sterilization right there. It's cheaper. It's in most cases. The only issue sometimes is folks who don't have enough water supply in order to sterilize the filters, and the filler usually is sterilized along with it. But yeah, so to me, steam's redundant. It's very easy to damage filters, and I think it limits the operation.
So what damage can steam do to the filter?
It'll melt it essentially, or it'll break it, because so since steam's a gas, if you have a wetted membrane to any gas, it acts like a wall. until you break that bubble point, it's going to resist that gas until it gets up to a high enough pressure. So on a 0.45 micron filter, that bubble point is going to be about 28 pounds pressure. So that's a lot of pressure at 210, 220 degrees, whatever the steam's coming in at, and that can physically break the filter because you're at that elevated temperature. Yep, go ahead.
Storage solution. What do you recommend?
Sure, so there's a few different ways for storage. So starting out in housing, so if you're going to store in housing, let's say you're going to come up the next day, most people just leave the hot water in there from the cleaning, and that's fine for a day, maybe 2 days. If you're going to store over a long weekend or a few more days, a lot of times the best thing to do is just push that water out with nitrogen, keep positive pressure on the housing. If you're going to store for a couple weeks, few weeks, then you can use a lot of different solutions. You can use peracetic acid, you can use potassium metabisulfate. A lot of the big chemical companies like Diversity and Ecolab will have things like Divasan, Oxonia. So any of those common storage solutions. The only two big no-nos, no high pH caustic and no ozone, which usually ozone's not going to be present at this part of the stage anyway. So that's in housing storage. One of the issue with a lot of those storage solutions though is that they lose their potency over time. So typically you have to drain and refill the housing with them every 3, 4, sometimes they'll go 5 or 6 weeks. If you're going to store outside the housing, so for instance, if a lot of smaller customers will only do a bottling once a year, they'll only bottle for 1 cartridge for a couple weeks or a month, and they need to store for 10 months, you can still use those same storage solutions, but then again, you have to refresh them. So for small customers, what I use and what they'll typically use is just 40% ethanol. So literally buy some cheap vodka, put it in a 3-inch tube, put the filter in there. It doesn't need refreshing, and as long as you don't have evaporation, you can even use that solution for multiple years. The only thing that you need to remember when you're storing a filter outside the housing is that since it's outside the housing, the O-rings aren't restricted, so they'll swell up, and then when you take them out of the solution, they'll shrink back down and they'll crack. So if you're storing the filter outside the housing, you always want to pull the O-rings and just store those on a shelf dry or something. And then the other important note with storage is make sure you rinse really well. We get a lot of calls from folks who've just stored a filter for 7 months, 8 months, and they failed integrity. There's nothing in that storage, as long as you didn't use high pH caustic, there's nothing in that storage that should damage the filter. So what's going on is you're not rinsing it all the way out, and that storage solution, particularly ethanol, will stay in the pores, and it causes the filter to have a different bubble point because it's different than water that the bubble point's developed around. So when you first put your filter in after storage, make sure you do a real good rinse, add a little bit of back pressure, so that way you're using the whole filter and you push that storage solution out.
Right, so you mentioned having a consistent flow rate coming into the filler bowl.
Yes.
What would happen if your pump keeps going on and off, on and off? Is there something that can go wrong there?
Usually so as long as you don't have water hammer, so a lot of times if pump's going on and off, sometimes you can have water hammer. So you want to watch those just from a pressure tolerance, make sure it's less than 80 PSID. If it's cold, if it's not CIP solution, then you want to make sure your pressure's not getting too high. But if your pump's going on and off, then usually the way your line's running is it's running off high speed, right? Because you're going to have the same output of your filler. So if your feed pump's going on and off, then typically you're running low speed, high speed, low speed, high speed. The goal is to run medium speed. So hopefully you could get that pump to run more often at a lower average speed.
What can be restricted the output of the cartridge?
You could do that, so that's going to increase your differential pressure. Most people aren't going to be able to increase their differential pressure up to a point where it would cause an issue with the filter. So that would be one option if you feel if you just want to slow down your flow to the filler by that way. Or sorry?
Or make it more constant, right?
Oh yes.
As opposed to slowing it down, that would make it more constant as well.
Yeah, because really what's pulling the wine out is your filler. Right. So you'd be slowing your feed into the filler. So yeah, you could restrict your outlet in that case to slow things down a bit.